Okay, so I want to talk about some of the Printf codes. So they talk about dictionaries where you look up words. It's a computer science term. If we say define company, that's a string company that looks up a string God Inc. So what you can do is this works in, okay, what you can do, let me just get to the bottom line. Okay. Okay, so if we say prompt, this works in many languages. And then if we say big S, that does the string indirection. So if we run this program, it didn't work. Wow. Let's see if that works. Okay. Well, you can see this is kind of a problem. First, let's do this. Let's call this my command. Okay, watch this. If I say Pig Latin, do you know Pig Latin? So we just iste ergs way inlay egg pay at Pig Latin. Okay, now if we say my command, so you can change the strings if you use string indirection with the big S instead of a little s, then you can change, you can, it supports many languages. So if I wanted to, I could go through all my operating system. I started with that, but then I said, no, I don't want that. What I want is I want somebody to modify all the code. It's only 100,000 lines. So this is kind of a problem. Can't put character turns and stuff. What there is there's define print. This is kind of cool. So this is a command, and we can put Okay. Okay. So now it works. So you can, it also works for lists. So we have support for lists. They're kind of ghetto. If you hit F1 and you go down to strings, or to characters, look for, okay, here's defines. This tells what the defines do. You can pick a sub entry from a list. You can print into a define. You can match a sub entry in a list. Let's go find lists before we do that. Lists. So I'm going to put this. Okay, so I think I should call that print define list print load. Oh well. First of all, let's do list. The month is, now if you say little z, I think you say 12 or 1 comma. That's enough. Okay. Okay. So what this is it's a printf with a little z, and then the Z commands have the index and then a list of 0 terminated. This is really ghetto. It's not fast, but it's handy. And okay, we need we want I plus 1, I minus 1. The third month, the month is March. My command 5. The month is May 2006. Okay, so you guessed it. You can make define list load months. This begins to get less ghetto. I think it's fast. I think it makes an array. And you use big Z, and you say months. So that's how that works. January. Now, so you can make Ticketmaster had what they called language modules, and if you wanted to define a language module, you would have several of these you would have several. You might put these in. You might have something like that, and one for each language. But so you get the idea. I'm not going to do that. Now, there's a truncate command. Check this out. Let's say you only want 2. Then what you do is you say %2 truncate. That'll take the first 2 characters. F5. Now, what if you want this system-wide? If you want this system-wide, you put 2 separate files. Then you do atom include. Now it's system-wide. So that's what we were just looking at. Okay, so we atom included, and now we should have months down here. Pop up. There should be a I got rid of them. F1 char routines. Define sub. Define list. Pop up. Pick define sub. You know what? Technically that should be listed up here too, shouldn't it? Pop up. Pick define sub. Okay. So pop up. Pick define sub. Subname. Okay, so we say months. So it made a list. So let's do February. That's number 1. It starts at 0. June is 5. Okay, so you can put this in your programs. Let's put it right here. And March. Now I truncated at 2. F5. February. Said FE. Okay, so if one task, okay, now tasks inherit symbols of parents. And if you don't have the symbol defined, if you define it with Atom in the Atom task, then if you don't have it, it'll use Atom. If you do redefine it, the new definition will be on top, and it will take the precedence. If it's not found, it searches parents. But if it is found, it does it right away. So anyway, I'm gonna, those lists of 0 separated are kind of slow, unless I think when you make a defined sub, I think it makes it run fast with an array of indexes, but it doesn't do a search fast. A search, but you can tell it to make a hash table. Fast to search, but you can tell it to make a hash table. Hey, not even anybody is watching. Nobody's watching. Fuck. So, what was I going to say? So we want to go fix that. There's a help index that's broken. We don't have, in the char define, we don't have pop-up define sub. So that means we have to go into here and say, let's char define. Now when we bail out, reboot, F1, char routines, char define, pop up, pick list. Okay, you can define a hash table based on a list, and then you can do a fast search. I wonder if it hash list add. Does the match use a hash table? I don't think so. I could make it use the hash table if it's available. How do you? Oh, do you use a hash table if it's a hash table? The hash tables have their own. What if I? Oh well. I could. Okay. So then you do a hash table find. Wouldn't that be? It'd be kind of cool if I. The problem with if I made the match automatically use the hash table, how big of a hash table do you want? I guess. Oh, well, I think I like it like it is. For the document commands, we made hash tables. It has to be pretty long before it gets worthwhile. These are all using the same hash table. My hash tables are designed for multiple entries. There's a type. You should look at my hash tables. HTT. So each task has a big hash table, as you can guess. This is kind of like the same scope as environment variables. It has global variables, classes, define strings. All of these are 1 bit in a mask, and you can tell it that you want to pick from, let's say you want all internal types and all classes, then you'd say 30. 30 would get you that. So I start using flags. This is kind of abusive. Not really. I have a very special or specific standard convention. G is for a mask, or this is for a lot of bits. F is for a single bit value. Little f is for a flag bit number. Bit number, not bit value. And I use T for types. This is a type bit number. So these are types. So you can tell right away what you're looking at. So these are bit numbers. The little f is flag. The big F is a bit value. I don't always define both. Sometimes I just define one and not the other. Here we're making a group. That's what it is. G is a group. Could use the word set. A set. Group, I like group. Set is probably, but what a S is kind of, I don't like S, I like G. So these are groups and flags. Where can I write this down? I thought I did write this down somewhere. In the documentation. Guidelines, maybe. Home files. Programming guidelines. Naming convention. This should talk about it. Groups are with that. Little f is bit numbers, bit flags. Okay. So mixed cap is functions and classes. All caps are assembly and define. Lowercase is local variables. Oh, you know what? Yeah, okay. I put an underscore if it's a pointer to a... Sometimes I use underscores in other places. So if you have a local variable and it's a pointer, like an output from a function, I use an underscore. I use underscore when I have an assembly. When I have an assembly, a C callable assembly, I put an underscore if it's C callable. If it's not C callable, then there's no underscore. So these are C callable. That's a convention. It's not a law. If it's not C callable, it doesn't have an underscore. And there's when you're converting, if you have a machine, if you have an assembly function and you're binding it to a C, okay, these are internal functions. This extern is a we're binding an assembly function, so you put an underscore extern, and then anytime you have an underscore extern or import, then you immediately there's an assembly label, and then there's the header for the C. So underscore extern. So we're taking these assembly variables and binding them to C variables. You can still, if you type sys boot base, it's a number. It's not. It's a number without any type. So this is a number without any type. It's an address. So if you say dump, that's. If you say you can say unassemble. So assembly is uppercase, and assembly labels are in the symbol table as externs. So let's say sys ram reboot. Okay, sys ram reboot. This is a number that doesn't have any type associated with it. It happens to be an address, so we can unassemble sys ram reboot. So there it is. If we bind it, we can bind it. We can say underscore extern. What if I? Yeah, that's extra. RAM reboot U0. Now, if I do this, it's gonna just call it. Okay, it crashed. I'm not too surprised. What did this do? Looks like it. Oh, RAM reboot. Oh, I think it requires a. Oh well, whatever. I shouldn't have done that. I should have done. That was not C callable, but that's. So let's go over this. If I say here, move RAX. Hello. Now we're doing a character constant. Now we say call put chars. So assembly labels are uppercase, and they use underscores. So what do we have right now? We have let's dump our symbol table. Who? That's a MATLAB command that I don't know if I like. That's what MATLAB uses, is who minus R, so it's not recursive. That means it doesn't include atom. So in the symbol table is an export syssim. It's just a number without any binding. Now if we say underscore extern here, now I didn't say it was C callable, but it is here. now I just bound it to C. So if it's a module, okay, you don't make, I decided my users don't need to make binary modules. So just in time is simpler a little bit because anytime you need a symbol, it already is there. Anyway, so you can now when you unassemble for a assembly symbol, you say here. For a C symbol, what would happen if we did this? Tell me what would happen. Well, I wasn't expecting that. Okay, I could have. Let's do this. $10,000. It's gonna return a value of 10,000. So oh, you can't redefine assembly symbols. That's bad, isn't it? So we have to bail out. So you have to run it with an F5 or just live with that. So now we have here, you can redefine C symbols. You can redefine; they just overshadow, but not assembly. Why is that? I forgot. I have to think about it. There's a reason. So it returns 10,000. So if I say unassemble here, we are looking at 10,000. It called the function, and then it returned 10,000, and that was done there. What we really want is unassemble address of here. Now it's the here function. So when you have addresses, when you have offsets of, let's say you want 100 off of, you do 100 off of here, or you do here. Now it's still showing up as address here. What do you think's in our symbol table? A function here, and so imports and exports are, so pretty much all the well, obviously we need the header for the kernel.bin and the compiler.bin. Those require headers. These three headers do those modules. The just-in-time code doesn't need headers. So all the code that's compiled in the Atom directory, these don't need headers. They just, if it's callable, you put a public on it, and then it'll show up in the help. If you don't have a public, it won't show up in the help. But other than that, there's no difference. So the public just makes it show up in the help, but it doesn't protect it. If you can call non-public, I want it that way. I want full access. So the public just makes it show up in the help. And these are compiled just in time at boot, and you don't need a header because it's compiling the code and it has the header. So just in time is better. You don't need headers. And you know what also, oh well, if you make a change to, let's say I go into the kernel and I change one of these flags, or let's say I renumber these flags 4, 5, 6, 7. Okay, now if your code is compiled at boot, those changes will not break compatibility. It'll still be compatible because those symbols, so there's not all changes are still compatible, but many of them are. Now what if I went to the Atom directory, and what if I added a default argument? Well, if it's compiled at boot, then that default argument will not break compatibility. There will be no compatibility loss if it's compiled from source at boot. So I try to do as much just in time as possible, within reason. I don't try that hard, but I have a kernel module and a compiler module that are binary, and then I have everything else in the Atom. I will break compatibility without thinking twice. If it's imperfect, I would change it. Like, for example, if I really did like S instead of G, I would change it. 10 years from now, if I like S instead of G, I would change it. You have to think of 1,000 years and what's perfect. Anyway, so our operating system is mostly for user programmers, and so third parties are not the priority. The user is the priority, not the third party. And so a user has his own code, and he can modify his own code if something changes. If you wrote the code, it's usually not too bad to fix it. You just have to be aware. I do try and post in the changelog, but I don't know how frequently you run a new version. Anyway, I think I'm done changing. I've been changing ruthlessly for 10 years. Do I change less? Perhaps. It doesn't seem that way. I still, just recently I overhauled the, I totally redid the D3. That was pretty rude, but it's a lot better. It's way, way, way better. So I just up and changed it. So, but there really isn't a lot of third-party software. Nobody's okay, maybe 1 or 2 people have written a program or two, but it has not got to the point where somebody shared a program. Nobody has ever shared a TempleOS program with a stranger. At that point, we're not at that point. Right now, it's kind of like a video game that entertains for 20 hours and then they set it aside. That's not terrible. I mean, I guess that's not what I want, but you know, you just have to be mature about it, and if it's a video game that entertains for 20 hours, well, I guess that's what it is. Anyway, so let's see what God says.